techniques that have been discussed are exploiting one or the other, the default design of the Android architecture. But that's there, and they are doing this kind of thing. And this is also a budding thing in the field of mobile security and the mobile malware, called as mobile malvertising. We talk about, like, in the recent time, we do, like, in the normal system level, when we get infected with the malware, there is a drive-by download occurs, you went to a third-party domain hosting black hole exploit pack, and a lot of other things. And the advertisements having an embedded with malicious links, termed as malvertising operations, they can also use this approach. Like in every single application, you can simply put up a flash-based, advertisement in it, and then put up a raw code behind it. And so whenever you launch an application, a certain kind of flash advertisement occurs on the screen, which actually gets connected back to the third-party command and control server and do some nefarious things if it is required. But this is also beginning to flourish in the world of Android. Previously, it was simply used for like advertisements, like simply put advertisements, get the click, and get the money out of it. But with mobile malvertising, a lot of things are changing with the passage of time. And the very interesting part is like hacktivism. I mean, I think I've seen like it started with this guy promoting a leader of, I think, Tunisian revolution. And so the simple perspective is that install an app that actually gives you an idea, or actually start promoting sending hacktivist messages to the different set of users. Typically uses a technique like simply replacing the images in your photo directory and a lot of other things. And the big problem is that when they use that, they actually send a SMS also with that, and the user has to pay for it. You simply get an access to the contact list, and then you can start sending these hacktivist spams and messages to that. But this is still there, I think, and it's still going pretty good at this point of time. Now let's take a look at mobile droppers and bots in action. Typically, if we talk about mobile droppers, again, if we can map this to the masqueraded application, droppers actually has a built-in functionality of melting itself. When we talk about the system level malware, dropper simply is an outer layer, a wrapper, which actually constitutes a malicious app or a malicious APK file. And that is being used, and it actually extracts that application and maybe deletes itself or try to act itself as a legitimate app. When we're analyzing some Android level, Android botnets, we've seen that there's an IRC-based communication that happened, one of the sample of Android malware, and that actually clearing all that logcat-c, clearing all the logcat functionalities, and then masquerading it in the PNG files. So the PNG file here acts as a dropper, which has a built-in malicious code. And that's how it somewhat looks like when you disassemble the code in the ARM binary, and then how the IRC login works, and how how it connects back to the IRC channel, and a lot of other things. So when you disassemble it, it gives you the warning that ARM and thumb mode switch instructions are not actually mapping up to this PNG file. But it's still there, you can keep on, and then you disassemble, and that's what we found while analyzing some of the malware samples. And if you talk about the difference between the badging, like how the different applications are set, I think the screenshot is pretty, you can see that, but these are some of the permissions that are used by the dropper, and these are some of the permissions used by the bot itself. And that's there, so the badging information varies with an APK file to the other APK file. Now, I just really want to talk about one of the Android malware and just a bit of the reversing, the kind of functionality it has. It is Android Golddream. It is one of the, I think, one of the best Android malware that we have seen. And I really want to dissect this Android malware because it has a lot of capabilities and other things rather than going for the simple application level malware. So let's take a look at it. So this is how it looks like. It's a blood versus zombie machine. It started, I think, originated last year, but it has a lot of cool functionalities to look into how it actually performs the URL modifications while communicating back with the server. And so if you take a look at, it looks for these kind of permissions. So Android Golddream was distributed using a Gamilio draw slasher package name. And it actually uploads the files in a stealthy manner using post communication. It just simply gets, so simply this kind of phenomena is used for data exfiltration. And Android Golddream does pretty well in using post one. It is one of the first variant that started using the post request for sending data. It simply extracts file from the different resources. It looks for the device information. Of course, most of the Android malware looks for it. And it has the calling capability. And the most interesting part with the Android Golddream is that the URL fracturing concept, like they try to build the URL that they want to connect at a dynamic runtime level. And if you look at this point, they actually use the concept of local objects and then simply use for get key node to look for the document object model variables. And so what these variables are actually, I mean, if you look at this in the static code, you say like, what the hell is this, from where this particular code is coming on? And since it's using local object files, we need to look into the shared object folders because that's where the local objects are placed. So on further analysis, you get all these static variables are defined in this way. But when you're doing analysis, our primary motive is to get the URL where they are actually connecting. And if we go further and look at the variables in the URL through get key node, it is actually defined in the local object space. And why not to look for the shared preferences? And when we do that, and we try to, we extracted all XML-based files out of the sample, and we started using a simple XML notepad viewer to view that. And from that point, we got that this particular XML file is pointing this particular variable with this particular time, and the end result is like gicp.net. That's where the mobile malware was connecting at that point of time. But the interesting fact is there because they are using this kind of techniques, and it makes really the static analysis really harder. But what happened when you try to look at the domain they are connecting and try to connect the dots where they're actually getting from and where are actually sending the exfiltrated data? So all these domains bring back some relation to the Chinese point, like Chinese domains here, service providers. So this one is a GICP net, which was first used by the Zeus itself. And if you go on the Zeus tracker and you do some background research, you will find that that particular domain was heavily used by the Zeus while spreading infection in the broad-based attacks. And that actually gives you the idea there might be some relation with the guys who are writing the Android malware and to the guys who are writing the system-level malware, exploiting the operating system integrity. And we'll take a look at some of the Chinese domain in connecting the dots. Let's connect some dots here and try to understand some of the really, really interesting. I spent considerable amount of time to just look at and try to see like what other different Chinese markets where we can go and look for other things, and what other things like what kind of malicious activities they are doing on the internet to actually attract the traffic from US or the legitimate domains. So this particular screenshot actually gives you the Android base bridge. It was like in the 2011, but that actually gives you an idea like all the alternative Chinese markets, they are spreading this package. They are actually hosting this package of Android base bridge, heavily used by the Chinese and the Russian, but primarily the infection started from China. Then I took a look at Android Latour, the Rage Against the Cage exploit. This particular sample used it, and I found pretty interesting results. Like these are the 4 screenshots I provided here, but there are many other alternative markets where this particular sample was served. So you simply go to, if, for example, any user going to these kind of markets, of course it's Chinese markets, but still when we're talking about protection level mechanisms, we consider every single scenario. And you simply visit it, you get APK, and by default nature of Android architecture, it gets installed and looks for other things. So this actually gives you an idea how different alternative markets and how largely they are spreading this kind of malware. Now I want to raise a very interesting study here, which I found while analyzing some malware. So there was a very, I think, a legitimate domain called as like Android Doctor. And it has this Android Doctor, the particular domain name was this. which were having an IP address, belongs to USA. Then there was like another Android doctor, but it doesn't have this name. It's different from this one, but it's so much close to that. It's like if anybody do like a typo squatting, it directly get redirected to the this particular domain, which is hosting in China. And if you look at the domain statics, that are completely different here. So if you look at the androiddoctor.com, it was like a Chinese website. And for example, consider a scenario like Chinese students who are staying in US and try to visit these kind of things, and they can reasonably be exploited by these things. So what I analyzed like some time back, just like a couple of weeks, like they took that domain down, and the new domain that was up was android-doctor, which is actually a legitimate one. So both the other domains are not active at this point of time. But this actually gives you like idea, like it's not typically related to the Android level malware itself, like in the device, but all these other things like brand jacking, typo and cyber squaring works really well for those guys. And so there is another interesting one called as an N-server bot. It was really I think like one of the best bot that has been written in the Android malware by the Chinese guys. And so if you really want to interest you, the analysis being provided by the NetShin and the researchers from the North Carolina state, I think they have done a great job. They have been doing this work. So how we want to take a look at this one. So since we are connecting the dots, we really want to look at the domains, because that's where we're going to get the way the traffic comes from and how they are interrelated and other things. So how we want to take a look. So we are trying to connect the dots, and the domain that we extracted after analyzing N-server bot was like cina.com.cn. And if you look at, this is one of the heavily used website in China that has a huge traffic, a large volume of traffic that comes every day. And I think its rank, Alexa traffic rank is 17, and it has in China, it was like on the number 4. But this website, this particular domain is being used for spreading malware. Let's take a further look at the global level structure of it. So it has a somewhat relation to the US too, and a lot of other things in the Asia. And this website looks like this. And it's been a heavy website in China. So when I started doing analysis, I found like I have some impression in my mind when I analyze system level malware, and I called to myself like, why not to look at the history of this particular GICP, because this cina.com, because I have seen some of the traces in the system level malware too. So I analyzed some of the trends, and I got this particular interesting one, and there's some like incidents happened in 2009 at that particular domain. And that was actually serving system level malware. So that particular IP was binded to this particular domain name. And this particular domain, at this present point of time, is still serving the malware. Like after 3 or 4 years, if you look at this particular subdomain, you can open a URL right now, it's still serving these things, which was reported somewhere in 2009. And the same domain was used to host the Android malware, because that particular N-server bot actually hosts some blog, which actually dynamically builds the path information to connect back to the command and control for the device. And if we look at this particular domain, it looks pretty legitimate, though they've taken it pretty recently down. But I want to raise a point here. This particular domain using this, and again, considering the fact of brand jacking, this is the same domain that is used by the net.cn, which is again a high traffic website from the China. And you can see there are a lot of difference that how these things are going on, how cyber squatting and typo squatting and the already existing domains are still serving those malware which are being used for the Android level. Now, what kind of defenses that we have at this present point of time? We have a previously leaked detection frameworks developed by some of the researchers, pretty good job, like Malandroid. We have a privilege escalation checkers, which are going to check like whether a particular application has privileges that is more than required. Call as a stowaway. We have a fine-grained control system resources. These are extensions that got installed at the Android platform level, Malandroid, Apex App Fence. Then there is a security policy enforcement to remove exposed interfaces at the application level, where we can use to send like hijacking intents or sending malicious intents and sort of things like that. We have a static analysis tools like Golddream and Woodpecker. There is an Android vulnerability checker. I think it's a pretty interesting exploit checker tool written by the Duo Security, and it's pretty good. And you have that. We have an Android Google Play application checker bouncer. It's still there. Sorry. And what is the new work is going on the field of Android, hardening the Android platform is like SE Android, Security Enhanced Android. And the idea is like to enforce the policy framework that is mandatory. But the big problem is the implementation of SE Android ad. It's going to take a lot of time because it has to, we don't know when it's going to be out in the market in a fully version state. And then after, it has to take a lot of time to get, embed into the Android level stuff, and then into devices, then vendors going to pick it up. So it's a heavy job considering the present day Android market. So there are much more to the Android malware, which I cannot talk about in this 60 minutes. But, so some of the big problems that I want to talk about is like, which is being there in the Android architecture. No code signing, custom code signing. Developer can sign with its own certificates. A process for repackaging. Native code execution. If an application fetches a code, it has to run inside the Dalvik VM, but not in the Linux, right? And that's why the vulnerabilities present in the Linux kernel allows to complete control of the device. Permission sandbox. For example, these are the actions without permissions. You don't require a permission for that, like receive boot completed and start on install. So you can start like a run once capability in Windows operating system. So you can simply use that and install malware. So the existence of alternate marketplaces, why no, we're going to implement like code signing and just host apps on the legitimate markets. Open source platform does not, say or raise a bar that we have to use alternate marketplaces for, distributing the apps. Google Play, Android market, there's some problems with their communication channel, how they are communicating back with their app, like the Google domain to download some other apps. No robust Android malware detection at network level. I haven't seen that there much research, or maybe I think like the researchers are going to do a lot of stuff in the network level detection of Android malware. So we use like concepts like honeypots and reverse honeypots, but not pretty much have been seen because we need a lot of signatures and dynamic building of signatures to do that. Another problem is the delay patch process, and that I don't think so it's a problem with the developers and the vendors because it's a coordinate problem. And considering the business that Android is bagging nowadays, it's a thing to look into. And the caution here is like, do functionalities like kill switch, when they send remove a set, or bouncer works against Android modern kind of malware? That's a big thing. No doubt the bouncer and the kill switch provides a protection against the standard set of apps, which are having leaking some permission, exposing interfaces, sending malicious intents or hijacking communication interfaces. You can remove that, but with the advanced level of malware, it's going to be a little challenging. So, and the real world question is, do users really care about Android malware? I was like going through a number of statistics produced by the third-party vendors and the third-party companies, and there is always a big caution. A majority of the users, do not care about this fact. Like, they just simply want the functionality, extensibility, mobility, and the power-oriented architecture of Android to play games, and they don't care about these things. But this is a big caution in front of us. No security mechanisms can be complete without users. So I think like some of our users have to be a little paranoid what they are doing about looking at their surfing habits and other things. So talking all about like Android malware taxonomy, insidious infections, we talk about like one of the Android malware. Then we talked about over the concept of Chinese alternate markets, connected dots, how the Android malware is somewhat related to the same set of domains that are used by the botnets. But the conclusion is restricted to this part. Users' awareness is required. We really need a strong defenses in the coming time, and that is, I think, it's a need of the time. Malware flavors are going to change in the Android world because with the advent of exploits such as WebKit level, the browser-based exploitation is going to increase. And I think one of the work has already been done by the TrustWave guys, like they have found a focus stealing vulnerability and that kind of thing. But again, it's an interesting fact, and with the change, the malware is going to change its real. And the malware will increase. There is no doubt in that. And with that, there's some interesting further reading, interesting work by some other researchers. They have done a great job, and I really push you guys to just look at some of their work. And we still have like 1 minute, 20 seconds for any questions. Yes? Please? I think it's going to ask a question. Yeah, please.
There's been talk online about the possible security features in the 4.2 release. Do you have any comment on that, or whether that's actually going to make any difference?
I think that post, if I remember, I think I have the post that I have read is about by the geosecurity, and I think it's they already doing a great work in the field of Android malware. First, I think they are going to impact the exploit mitigation level, but it's still going to get advanced. But with the standard set of exploits such as Gingerbread, which I mentioned earlier, exploit the global offset table, that's not going to work. Kind of things gonna work over the latest version on Jelly Bean. I think the Android Jelly Bean is really, really advanced. They have really changed a lot of settings related to address space layer randomization stuff, ELF hardening, and then exposing the interfaces and address as the kernel level. So I think it's really going to change a lot of things. But again, the existing market still running on the Google Android Gingerbread version. So that's the thing is. So if you have any other questions, I'll be available and we can still have a chat and learn from each other. Thank you very much.